A very warm welcome on the behalf of organizing team of the conference. We welcome you, Dr. Rana sir and Dr. Ashwini sir. I am audible, sir.
Thank you, sir.
Yeah, thank you, sir. Thank you.
Shall we start, sir?
Yeah, sure.
Okay, sir. Thank you. Dear participants, we have two session chairs. One is Dr. Rana Mukherjee sir and another one is Dr. Ashwini sir. Dr. Rana Mukherjee is currently working as a professor in ICFA University, the ICFA University Jaipur. He is also a PhD coordinator of the university. He was also the founder president of the Institution Innovation Council of ICFA University. In his academic career, he spent over 17 years and he has been associated with the Institute of Technology and Management, presently in the Sangam University, Bhilwara. He is a fellow of IETE and senior member of IEEE USA, IRAD, and many more. Apart from his, he is also actively associated with the several prestigious professional bodies like ACM, USA, and Educational Consultant of India Private Limited. Dr. Mukherjee has also earned recognition by being elected as a member of IEEE Rajasthan Subsection Executive Committee for the year of 2020 and 2020-21. He is also the founder chapter secretary of IEEE Censors Council in Delhi. Dr. Rana Mukherjee sir, we welcome you.
Thank you, sir.
We have another session chair, Dr. Ashwini Kumar Yadav. Dr. Ashwini Kumar Yadav is an associate professor in Amity University, presently in the Department of Electronics and Communication Engineering. His research interests include the image processing, VLSI design, optimization techniques. He is a 13 years of teaching and research experience. He has published 3 patents, 2 books, and around 54 research papers, including SCI and Scopus. He has also organized various conferences, workshops, seminars, and FDP. He is also serving as an editorial board member, reviewer of the reputed journals and conferences. He has also done, he also guided PhD. Sir, welcome you. Now we start the session. Deepak Kachot, sir.
Yes, sir. Available, sir. Good morning, sir.
Good morning, sir. Sir, share your PPT first.
Yes, sir.
Dear participants, we have 88 minutes of the presentation and followed by 2 minutes of your queries. Hello. Yes, sir. Deepak sir is visible.
Okay, sir. Shall I start, sir?
Yes, sir.
Good morning to all. Today I am presenting this paper, which is based on the recent advances in the field of natural fiber polymer composites. My name is Deepak Kachot. I am a PhD scholar at Amity University, Rajasthan, and I am working under the guidance. I am doing my PhD under the guidance of PK Birds, which he is my supervisor. On this discussion, we will discuss the introduction of the topic and why this topic is chosen, the objective behind it, the literature survey, what we have did our literature, what the other persons have worked on it, then summary, then conclusions and future scopes. Now come to the introduction part of this topic. Here we are discussing about the fiber reinforced polymer composites. So first of all, what is it? It is a composite material generally which is made of a polymer matrix with the fibers. The fibers may be generally used as a glass fibers, carbon fiber, aramid fibers, polyester fibers, like that. The first fiber reinforced composites was developed before the 1939, but its application was increased when during the World War II, when the requirement of lightweight material was increased. It means it already shows the importance of importance of this polymer composites during the World War. But due to the low strength, it could not more popular at the time. Now during the 1970, when the synthetic fibers and various resin were invented, it completely changed the research scenario. Now the more focused was you can say diverted to enhance the mechanical properties of plastic by reinforcing some synthetic fibers into it. The synthetic fibers shows a good mechanical strength, but you can say synthetic fibers may be glass fiber or carbon fibers. Generally, it is used with the polymers, and still there are a lot of components are you can say fabricated in automobile industries, in aerospace industries, in ship manufacturing industries using the synthetic fibers. Although the synthetic fibers are good enough, but due to the known biodegradable properties and health hazards, it creates ecological problems. That's why there is a need to find a new alternative fibers which can not only replace the existing fibers like a synthetic fibers, but it should be easily available. The fiber should be cost effective. It should be a biodegradable, or it should have a high specific properties. So from the lot of research, it is found that if the natural fibers are used in the replacement of the synthetic fibers, these can fulfill the above desirable requirements. Now the current research is focused on to find out the appropriate natural fibers through which the desired mechanical property can be achieved. So the natural fibers, if I categorize the natural fibers in general, it is in major three categories, which is a plant-based, animal-based, or mineral-based. The plant-based fibers which are extracted from the plants, animal-based fibers which are getting from the animals or humans, like human hairs or animal hairs, or some minerals. It may be asbestos, graphite, glass fibers, and you can see that these all are renewable fibers and these all are biodegradables. It means what I can say, these fibers are having a less cost, low density, minimum health hazards, less pollution, and eco-friendly also. That's why here we decided to work on natural fibers rather than using the synthetic fibers. So where we can use these type of composite, as I told you, generally we can replace the synthetic fibers with the natural fibers. That's why it can be used in automobile industries, in aerospace industries, in construction industries, in packaging, electronics, and sports industries. So what is the objective of choosing this type of topic, natural fibers? Here we are concentrated our topic, which is a hair fiber based reinforced composites. And here we will discuss the factors that may influence the performance of hair fiber reinforced polymer composites. Why here we are choosing only the hair fibers? Because there are a lot of research already published which are based on the plant fibers, and already we have discussed what is the plant fibers. You can see the hemp, sisal, jute, quinoa, flax, these type of fibers extracted from the plants. So there are a lot of research has been done and published nowadays, but a very less reviews articles are available which are related to the hair fiber reinforced polymer composites. Now, what we studied here, I not included all the papers. Generally, we studied more than 30 papers related to this hair fiber-based polymer composites only. So, some of the important papers I have included in this PPTs. Like you can see here, the Nitish Kumar and his team worked on the fabrication and fabrication mechanical characterization of horsehair reinforced polypropylene composites. As its title is showing that here they use the horsehair and polypropylene. Horsehair is a fiber, natural fiber, and polypropylene is a matrix. And after that, they fabricated a composite using these horsehair and polypropylene, and they conducted a test, which is a tensile test, flexural test, impact test, and water absorption test. And here I am trying to showing their results. What they did, they varies the percentage of horsehair and polypropylene. In the first mixing, you can see that they fabricated a composite which is the only based on the 100% polypropylene. It means they did not mix any horsehair into it. And after that, they form a next sample in which they mix the 10% of horsehair into a 90% of polypropylene. At the same way, in sample third, they mix a 20% of horsehair and 80% of polypropylene. And in another sample, they mixed a 30% of horsehair and 70% of polypropylene. When they tested these samples, they found that the best mixing ratio was 20% of horsehair and 80% of polypropylene. It means this is the you can say optimum composition. It means we mix the 20% of hair fiber into a 80% of polymer, then it can give us the good tensile strength. The same things you can similar results you can see in this flexural strength. Again, they tested the same samples to find out the flexural strength. Again, you can see that the composite which are having a 20% of horsehair and 80% of polypropylene shows the good results. Also, they used these samples to test the impact strength with the help of this RP impact test, and they found that again very interesting result you can see here. The percentage, the mixing, the weight percentage of 20 weight percentage of horsehair with 80 weight percent of polypropylene. Again, these compositions gives the best result as compared to the other compositions. Again, to check the water absorption behavior of such type of the polymer composite, what they did, they submerged this sample into a water for 24 hours, and they found that as the you can say the horsehair percentage is increasing, the water absorption behavior is also increasing. So what we can say that it means if we mix the horsehair 20% of horsehair into 80% of polymer, then this sample gives us the best results according to their results. When I found another article which is based on the mechanical characterization of animal fiber based composites, this is published by the Nitish Kumar and his team. They also worked on the horsehair, but they used a polylactic acid here as a matrix agent. And also they found they conducted some tests like tensile test, flexural test, impact test, and water absorption like we have discussed earlier. And from their test result, again we can see the similar results already we have discussed earlier. You can see that here the first sample was fabricated using the 100% of polylactic acid. Here 10% of horsehair was mixed into 90% of polylactic acid. 20% of horsehair were mixed with the 80% of polylactic acid. At the same way, 30% of horsehair were mixed with the 70% of polylactic acid. And here again we can see that the 20% of horsehair is mixed with the 80% of polylactic acid. Again, this sample gives the best result as compared to the other samples. It means the tensile strength is highest at a mixing ratio of 20% of horsehair with 80% of polypropylene in case of weight percentage. Again, the same result can be see here the tensile modulus. The result of tensile modulus also it is good in case of 20% of horsehair and 80% of polylactic acids. Again, they tested a flexural strength. They found that the sample of 20% of horsehair and 80% of polylactic acid gives the best result as compared to the pure polylactic acid or any other mixing of horsehair with the polylactic acids. The flexural modulus, again, it is giving the same result as a flexural strength. The ratio of 20% of horsehair with 80% of polylactic acids gives the best results. Also, they tested the impact test using the ISOD impact test techniques, and they found that the sample of 20% of horsehair with 80% of polylactic acid gives the best results. So, what we can conclude that we can see that it means if we mix the 20% of fiber, you can say weight percentage into 80% of polymers, then it can give the good results. We can optimize this mixing ratios through these results. They also, Nitin and his team also tested a water absorption behavior of this composite. They found that as the percentage of horsehair fibers is increasing into the polylactic acid, the water absorption behavior is also increasing. So it means the water absorption behavior will depends on fibers percentage into the composite. Here in this paper, which is published by the Dayadi Rao, and they investigated the mechanical property of hybrid goat hairs and banana fibers. Here they not use only a pure hair into the polymers. They mixed a hair as well as the banana fibers, and they mixed these two fibers into a polymer composites. Here they use a epoxy for mixing of these fibers into a polymers. So in this that test result is showing that if only the pure epoxy is used for the fabrication point of view, it gives the very less result. If a goat hair is mixed with the epoxy, it's you can say tensile strength is increasing slightly. Banana fibers is mixed with the epoxy, again its tensile strength is increasing. But if banana fiber and goat fiber is mixed with the epoxy, you can see that it gives the highest tensile strength as compared to the other mixing ratio. It means we can think that if a hair is mixed with the plant-based fibers, then also we can increase the tensile strength. The tensile modulus also showing the same result like as a tensile strength. Here also the banana fiber, goat fiber and epoxy fibers giving the best result as compared to the other mixing ratio of other fibers. After the flexural test, they found that the test of the flexural test also they found very good. Although the banana fiber showing the good results with the epoxy, but if banana fiber is mixed with the goat fibers and fabricated with the help of epoxy, slightly the tensile strength, slightly the flexural strength is increased. But here we can see we are getting some differences between these two. And the flexural modulus also, it is clearly seen that the flexural modulus is very much high as compared to the banana fibers, pure banana fibers and epoxies. In another paper, which is published by P. Rao, they worked on the tensile studies. They only studied about the tensile behavior on random-oriented human hair fibers. They used a human hair fibers. Earlier, we discussed the animal fibers. So they mix these hair fibers with the polyester uh, resin, and they found and they only performed the tensile strength test. But what they did, they changes the fiber weight ratios to find out the tensile strength of human hair, reinforced polymer composite, and in another sample they change the fiber length to find out the tensile strength of human hair, fiber reinforced polymer composites. From that test, it can easily seen from here that the 30 millimeter, you can see the fiber weight percentage, which is you can see here 20 weight percentage with 80% of the polymer is giving the highest test results in this result also, in their result also. And if I talk about the fiber length, you can see that 30 millimeter length of the fiber give us the good strength as compared to the other fiber length. You can see it is they worked on 50 up to 50 millimeter range of the fiber length. It means what we can conclude that the chopped fiber gives the good result as compared to the long length fibers. They also find out the void, you can say presence of void volume content in fiber weight ratios. You can see that at 5% to 10% the void percentage is increasing, but when we are increasing the fiber weight percentage into the polymer, you can see the percentage of the void is is decreasing very drastically. But when we are increasing the weight percent of the fiber into the polymers, more than 20%, you can see the void percentage is also increasing. Got it? And again, they found the density. They conclude that as the fiber percentage is increasing into the polymers, the density of the composite will also be increased simultaneously.
Yes, Deepak ji.
Yes, sir.
Okay. You are on summary, na?
Yes, I am on summary.
Fine.
So what
whatever you are finding, na? Just
yes, this is my finding, sir. Out
Fine,
of this
fine.
paper, this is my finding. I'm just concluding these things. So what I can summarize the whole, you can say, work, the effect of chemical treatment on the tensile strength. What we can see that if untreated human hair fibers is used to form a composite, it gives the less result if we use the treated human fibers as compared to the untreated fibers. But the improvement is slightly very much less. Here again, a pig hair powders also used some scientific work on it, and they found that the treatment of hydroxide acetylate is very much less as compared to the carbonized pig hair powders is used for the fabrication of composites. Effect of chemical treatment on flexure strength. It also gives that untreated human hair fibers and treated human fibers. It means the treated human hairs gives the it can improve the flexure strength also. Effect of variable hair fibers. It means we are varying the percentage of the fibers into the fabrication point of view. You can see that the 20% of fibers with 80% of polymers can give the best result. Here the various composition are shown here using the human hair, using the horse hair, using the you can say hybrid fibers. Effect of variable hair fibers loadings on flexural strength. Also we can see that the 20% of mixing with 80% of populate, it can also enhance the you can say flexural strength property of the materials. Effect of hybrid hair fibers. If more than one fibers is used for fabrication point of view, it also can increase the tensile strength as well as the flexural strength. So what we can conclude through these results, from the research analysis found that very few work has accomplished in the field of hair-based fibers as well as the hair fibers hybrid composites. It means the hybrid fibers. A lot of animals' hairs can be used to check the compatibilities with the different polymers to improve the performance enhancement of hair fibers composite. Still, some work can be done in the field of chemical treatment of the fibers and mixing of hair fibers with different type of plant-based fibers with the different bonding agents. So these type of work still can be do in future, because very less work is done in these hair-based fibers uh, by varying the different type of animals. Or so these are the papers we have studied for it. Thank you from my side, sir.
Yes, Dr. Rana,
Any
sir.
suggestions?
Sir, I just want to ask how this hub is renewable. You have shown in the second slide the
Yes, sir.
advantage of this as a renewable. So how you can clarify or justify how these fibers composites are renewable?
Sir, as I told you that these fibers are natural fibers, and these are not man-made fibers. That's why we can see these fibers are renewable.
The second is have all these papers use the same techniques for sample preparation? At what temperature and whether they have used a vacuum or air for
No,
are
sir.
they annealed for that or sintered in any environment?
No, sir. Actually, most of the time, generally, as I studied from a lot of papers, they are most of the paper are using a hand layer process. But compression molding process and vacuum process also can be used for fabrication of these composites. But most of the researchers are using the hand layer process, and their results are similar as much as the compression molding process, the vacuum molding process.
Which is better, whether it's a human hair, banana fiber, or horse hair?
Pardon, sir?
Which is more renewable, human hair, banana fiber, or horse hair?
Banana fiber or horsehair fiber? Which one is
Which
most
is
renewable?
okay? Which is better?
Which is better, sir?
Yeah.
Horsehair having the different property. As you know, the horsehair having a more tensile strength. So that's why we can see that horsehair is good as compared to the banana fiber. But if I talk about the availabilities, the horsehair availability is very much less as compared to banana fibers.
Thank you, sir. Thank you, sir.
Thank you, sir.
Okay, Deepak ji, one question from my side.
Yes, sir.
So, the main property you identified or reviewed from these paper is tensile strength and modulus, na? Tensile modulus.
Yes, sir.
So, is there any specific difference, and this property is important for finding these type of natural fibers?
Sir, tensile strength, what I can say, it is a strength through which what load can be beared by the object. Okay. Then the tensile modulus means we can say that it is showing the stiffness property of the object.
Stiffness.
Yes, sir.
So you need
It
more
can resist the
stiffness
force.
or flexible. What type of material fibers?
Elasticity
you want
property.
to
What
have?
we can say it is a more elastic. It is a more elastic.
If modulus is high, that means elasticity is higher.
Yes. It means it
Okay.
will not break.
Fine. So one suggestion from my side: whenever you review these kind of papers, around 30 papers you reviewed, so that conclusion or that identification should be present in a tabular form with the various parameters. So that will be more explanatory. Itself table can explain that these are the constant parameter and these are the variables which we have identified.
Okay, sir. Okay. Next
Overall,
time, sir,
all the best. You presented well, and this topic is very interesting. Thank you.
Thank you, sir. Thank you.
And now next is Vinod Kumar Sharma ji.
Yes, sir.
Yeah, are you ready with your presentation?
Yes, sir. Yes, sir.
So you can share your screen and start presentation.
Sure. The screen.
After,
Yeah.
yeah. No, not shared right now. After Vinod ji, Vishal Vishal Wankhede. Please be ready. After Vinodji, it's your turn. Then Manoj. Then Mohammed.
Sir, I am ready. I am ready. Vishal.
Yeah, sure.
So
And Vinodji, one more thing,
Yeah.
because we have less time, everyone should stick with the time.
sure.
8 minutes for presentation, 2 minutes for query.
Yeah, sure, sir.
So conclude and focus on your contribution only.
Yeah, my screen is visible, sir.
Yes.
It's visible.
Yes, you can proceed.
Okay. So myself is I'm Vinod Kumar Sharma, PhD research scholar, Manipal University, Jaipur. Here today I'm going to present study of flexible antenna, a review. So good afternoon, everyone present. Good morning, everyone present in this meeting. So this outlines of my presentation is introduction, objective study, literature review, scope of the study, applications, and references. So here you can see this is the introduction part. That is basically we have to start from the flexible electronics. So today the flexible electronics we are using everywhere. There are the different various application of flexible electronics. Either you can go for that is the for energy harvesting, energy saving, biomedical, that is for health monitoring, either for agriculture. So even this communication is not communication also touch this field. There is the various application of the flexible electronics in the communication field. That is the antenna designing. Here you can see that is this type of that is RFID tag is here. So that is the flexible antennas we can design. Why? What is the requirement here? What is the best application of that one? Because we can put this is in the flat antenna we cannot put the human body. If the antenna is flexible, that can be easily put on the human body in the form of either a wristwatch or a band, or even it can be implemented in the inside the body. So what is the flexible electronics can be currently considered as Bell steel wire technology that has reached a certain degree of maturity in meeting the requirement of the tight assembled electronic package, providing reliable electrical connection where the assembly is required to flex during the normal. So what is the requirement for this? The main requirement for flexible electronics is the flexible substrate. So it can be bent easily, it can be stretched, it can be twisted. So for this purpose, that the packaging of wireless communication device and sensor network is required. So this is the literature review. Here I will go through these papers. So many papers I will go through, but some papers I have put here. You can see here, this is the basically this object is to design flexible electronics by using the nano composite material. So in this paper, that is the King Jong study of nano magnetic dielectric substrate for compact antenna application. This is for frequencies 2 GHz and the material used the magneto dielectric. In this another paper, that is the compact square loop patch antenna on high dielectric ceramic PTFE composite material, that is the design for frequency of 2.4 GHz. That is for ceramic polytetra. This another is antenna array bandwidth enhancement using polymetric nano composite substrate, that is for magneto dielectric. Because our object is to enhance the bandwidth of the antenna also. There is the problem with the microstrip patch antenna is the narrow bandwidth. So there are so many ways by which we can enhance the bandwidth is there. The one way is the using the correct material or choose the proper material for designing of antenna. In another paper, that is the bandwidth enhancement of a microstrip patch antenna array using magneto dielectric polymer substrate, that is PDMS Fe3O4. Here this iron composite, the nano composite, it is mixed with the PDMSA, that is the polymethylation. That is the one type of solution is there. So when we mix this Fe3O4, it will not confine its size and it will give the great flexibility. In another paper, that is the preparation of flexible substrate for patch antenna based on nickel aluminate. that is for 2445 gigahertz frequency. Oh, sorry. So in the next paper, this is for 2.0 gigahertz patch antenna on biocomposite substrate using the quarter wave transmission line. This is for 2.4 gigahertz DNA. That is for high density polyethylene. Another paper in which comfortable patch antenna designed for remote health monitoring. This is for CNT based carbon nanotubes polymer is here. And in the design, fabrication and characterization of polyethylene and multi-wall carbon nanotubes composite based patch antenna, they use the antenna design for 4.5 gigahertz. In another paper, they have the synthesis and characterization of low loss Fe3O4 PDMS magnetodielectric polymer nanocomposite for RF application. Here in this performance analysis of cobalt metal with the fluoropolymer matrix is substrate for patch antenna. This is FR4 and cobalt metal with fluor matrix is there. In another paper, they have also used fabric. In this paper, that is the effect of changing substrate material and thickness of the performance of insect feed microstrip patch antenna. The frequency, this is for 2.4 gigahertz. So why this materials for the flexible antenna? Basically, there are the two type of material required for the flexible antenna. One is for its fabricating of patch. That material is copper nanoparticle, silver nanoparticle, PDMSE that I've discussed already. That the carbon nanotubes, nanoflex, papers, and even people are using the different cloths is there also. So that what are the characteristics for this? It's must be we have to compose two materials. So the flexible characteristic may be generated here or it will create it. And other material is for its substrate. So for the substrate purpose, that is nothing. It's for gives the mechanical support or mechanical strength of the patch. So for this required either it may be thin glass, metal foil, copper coated rubber, ethyl vinyl acetate. Other materials also there. What are the different fabrication techniques? The fabrication techniques depend on what type of material is there and what are the application of these antennas. So there is basically these techniques are wet etching, inkjet printing, screen printing, embroidery. In the most of case today, the researchers are using the inkjet printing techniques in which we have to print the this patch on the substrate. What are the different applications of flexible antenna? You can use the this flexible antenna for purpose of Internet of Things, designing of different type of sensors, use for health monitoring, design for flexible sensors, wireless sensors network, communication devices, etc. What are the scope of this study? The study focus on improve the characteristic performance of the flexible microstrip antenna, how we can improve the characteristic of antenna, either this is gain, bandwidth. Those antenna which are designed on flexible substrate, the resonant peak frequency remains unaffected after bending, stretching, and twisting. So the antenna must, when we have to stretch this antenna, either we have to bend it antenna, either we have to twist this antenna. So the resonance frequency must not be changes in any case. Flexible substrate based antenna design are rapidly emerging as a popular choice for radio frequency identification purpose. These are some references here. So thank you very much, sir. Hello.
Okay.
Hello.
Yes.
Yes. Yes.
So well done, well presented. Yes, sir. Rana sir, would you like to ask a few questions?
So first you just ask.
Yes.
Okay. So I'm just very curious about this flexible antennas. So
Yes,
right
sir.
now, I think this is in use. Practically, we are using these kind of antennas.
Yes.
So what is the main technology behind that? So you can improve the properties or this like bandwidth if you want to increase it.
Yeah.
So
Actually,
what process is required?
yeah, actually, there is a lot of techniques there. That is basically we can change the substrate material. One technique is there. Second technique is that we can just even to improve some focusing on the frequency. So what we can do, either we can add some another that is a circularity. Either some diode is there, other things that can affect its frequency. Other technique is that is the size is also one important parameter, and the material of patch is also important parameter. So here the dielectric constant of the material also one parameter, because the resonance frequency is depend on the dielectric material. If we change the dielectric material of the substrate, then we can change, then we can improve the this resonance frequency of the antenna or enhancement of the frequency.
So have you identified any material which is best in overall way from these review papers?
Yes, sir. Actually, this is PDMS FE304. That is the material that we can use for the flexible antenna purpose. Most people use, either you can go for carbon nanotubes is there, other material there, but from my point of view, that is for my research point of view, that is the PDMS FE3 I have identified. So I'll work on that one.
Okay. Yes, sir. Rana, sir.
I just want to know any research gap you have found in these papers.
Yes, sir. Actually, this is the main concern is there. We have to, size is one important parameter. We have to, the small size antenna is required. So for a small size of antenna, we have to, how we can reduce the size. So we have to find out the such type of material that is for antennas already available for the FR4 other material there. So this is my concern is to mix up two material. So it will reduce the size that that's the flexible substrate size.
Thank you very much.
Thank you, sir. So can I leave, sir?
Yeah, you can.
Yeah, thank you very much, sir.
Yeah. Next is Vishal Wankhede. Vishalji, you can share your screen. Yes, it's visible. You can start your presentation.
Is that visible?
Yes.
My screen is visible with you?
Yes. You can start.
Yeah. Good afternoon, all of you. I am Vishal Wankhede, PhD scholar from University Jaipur. My paper topic is mechanical characterization of natural fiber reinforced polymer composites. These are the content of the presentation. In this paper, I am trying to study the mechanical properties of the natural fiber reinforced polymer composite. Basically, I am taking two natural fibers, that is Munja fiber and jute fiber. I vary the weight percentage of this fiber and I'm analyze the basic mechanical properties of this fiber in the study. The weight percentage of fiber are varied in a 3% and 5% respectively. The natural fiber reinforced composites are recent popular materials used for various engineering applications. In natural fiber reinforced composites, natural fiber are used as a reinforcement constituent because of the various advantages like low cost, non-toxic, light weight, renewable, possess good mechanical characteristics. Epoxy resin is the most popular matrix material used with the natural fiber reinforcement for forming composite. Epoxy resin has lots of advantages like easily availability, good mechanical properties, resistance to corrosion, resistance to erosion, non-toxicity, etc. In this study, we are taking a jute and Munja fiber at a weight percentage of 3 and 5% in a reinforcement phase and epoxy resin in a matrix phase. Materials and method. Basically, we are using two type of natural fibers, Munja and jute fiber. Munja or Saccharum Munja fiber are common, comes from Munja plants, which are abundantly available in the India. Traditionally, this fiber is used for making ropes. In this study, we are taking a 15 mm length fibers for a reinforcement phase. Jute fiber are the fiber which are produced from the jute plants. India is the largest producer of the jute fibers. Traditionally, jute fibers are used in a various applications like for making rope, bake, carpet, paper, cloth, and various household applications. In this study, the jute fibers are taken in a 15 mm length. Both the fiber Munja and jute fiber are taken as a short fibers and of a length of 15 millimeter. For matrix material, we are using epoxy resin. Epoxy resin is the most commonly used matrix constituent used in the it is used in a continuous phase with the natural fiber reinforcement. In this study, the Atul Limited Lepox, Matlam System B epoxy resin and Matlam System B hardener are used in the ratio of 2:1. For making sample, I am using the hand layer process. It is a most cheapest process for making the composite. We can make a composite of any size by using this method. The constraint of this method is that the geometrical shape must be simple. I am using the hand layer process with the open molding. We are added the layers of the fibers and the resins one by one, and the composite samples are prepared by using this method. The curing is take place at a room temperature. For the experimentation, there are basically 4 types of samples are prepared. First one is a 3% Munja fiber sample in which the fiber is present. The Munja fiber is present at a 3% weight. And 5% Munja fiber composite as a similar as 3% jute fiber composite and 5% jute fiber composite. These are some samples prepared for the tensile test. The tensile test is carried on the universal tensile machine, in which the load is applied on the both side of the test specimen. In a flexor test, this is also carried on the universal testing machine. It is a destructive testing procedure in which a flat specimen is placed horizontally on 2 adjacent lower supports of UTM, and the load is applied on the center of the top of the surface. This test gives the value of flexural strength of the specimen. Impact test was carried out on the impact testing machine, and an ISOD type of procedure is followed. Testing procedure is followed. These are the results of the test. Tensile testing, flexural testing, and impact testing results are here. This is a graph between the tensile and flexural strength of the different composites, and this is a graph for impact strength of the composite. As a result, that 3% Munja fiber epoxy specimen shows a tensile strength of 24.2 megapascal and a flexural strength of 30.1 megapascal and an impact strength of 21.8 kilojoule per meter square. Similarly, the 5% Munja fiber epoxy specimen shows the tensile strength of 27.3 megapascal, flexural strength of 33.2 megapascal, and impact strength of 25.6. 3% jute epoxy composite shows us a tensile strength of 30.3 megapascal, flexural strength of 35.4 megapascal, and impact strength of 29.2 kilojoule per meter square. And the 5% jute epoxy specimen shows a tensile strength of 34.9 megapascal, flexural strength of 41.1 megapascal, and impact strength of 33.4 kilojoule per meter square. These are also tabulated here. In conclusion, we can say the result of tensile, flexural, and impact strength. The 5% jute epoxy specimen shows the highest values for all these tests. The highest value for a tensile test is 34.9 megapascal. For a flexural test, it's 41.1 megapascal, and for a impact is 33.4 kilojoule per meter square. In a future scope, like here in this study, I'm taking a jute and Munja fiber of 15 mm length. There is a future scope to vary this length, maybe 10 millimeter, maybe 15 mm, maybe 20 mm. I'm using a short fibers over here. In a future scope, anyone can use a long fibers and study. Here the weight ratio is taken as a 3% and 5% for this study. We can also vary this weight ratio because while we are varying the weight percentage of the fiber, there is an increase in the mechanical properties like in the tensile strength, flexural strength, and impact strength. So we need to study at where or say up to which limit that strength is increases and while that will be decreased. These are the references.
Yes, Vishal, have you, that means these parameters or properties has been calculated experimentally by you?
Yes, sir.
So on which machineries or tools do you completed these tests?
So for impact testing, there is a impact testing machine is used, and for tensile testing, there is a UTM, Universal Tensile Testing Machine is used. The flexural testers also perform on that machine.
So is it available in MIT?
No, sir. I am from Indore, so I am taking test at our institute.
Where it is?
It is at Khandwa Road, Indore, Swami Vivekananda College of Engineering.
Okay.
Okay. Fine. So what was the sample size in your case? How much these jute and have you considered? Is there the impact of the weight and size of that sample? Is there any effect on these parameter mechanical properties?
At present, the sample size are as I'm making the samples by the hand layer process. So I am prepared a sample of 300 millimeters in the length and 10 millimeters in the thickness for the tensile testing.
Fine. Rana sir, anything else?
No, sir. No question from my side.
Okay. So now Manoj, the next one is Manoj.
Yes, sir. Good afternoon. Hello, am I audible, sir?
Yes. Audible Manoj. You can share your screen.
Right. Okay. Is my screen is visible to everyone, sir? Please. No, just a minute.
Not now, Manoj.
Yes. Just.
Yes, it's visible. You can proceed.
Okay. Good afternoon, one and all. I am Manoj Sharma. The paper, my topic of my paper is basically prediction of mechanical behavior of natural fiber field polymer composite using the analytical approach. Basically, sir, my work is on natural fibers, and basically, I am going for analytical approaches. The modeling techniques are there.
So yes, Manoj, can you do one thing? Because this is the again same topic you have also done on the natural fibers, na?
Yeah.
So how your work is different with the previous one, that Vishal's work? You just focus on that part only.
Sure. Definitely, sir. Here, sir, basically, I am going for analytical approach. I am going for modeling approach. I am not going experimental work. So in this paper, I am discussing about the modeling tools or analytical tools for the natural fibers. And also I am changing my fibers for the composites, sir. So as a part of my content, I am focusing on the introductions. That definitely objective of my work. Materials and methods means what techniques, what analytical techniques I'm using here for the variation of properties. Result and discussions, what plotting I'm getting from the results from modeling techniques, and of course the conclusion and scopes. Sir, basically here, as already previous speakers are told, the natural fibers and fillers are the key materials for nowadays for replacement of the additional materials. So it is a huge attractions for this material by various researchers in various applications based on the needs. Even in automotive applications, even various areas where we need the natural fibers, where we get the strength, and we can changing the properties also by changing the volume fractions. So if you are adding this fibers or oblique fillers for the particular applications and particular percentage, then we can get the our material also and giving the what are the benefits, environmental as well as the replacing the traditional materials. So basically what we are doing for the preparation of development of the composites, we are first prepare the fibers, go for the matrix selections, then make the composite, and maybe use any techniques, maybe hand lab process, as here I'm giving here in the flow charts. Maybe go for hand lab process or any techniques, and then go for characterizations. So the characterization is basically connected with the experimental work or the modeling approaches. So here, these are the experimental approaches, but I am applying the modeling approaches for this particular paper, sir. Means we can guess the behavior of the composite by using the modeling approaches also. But with some assumptions are there, the experimental techniques are giving the close results. Even the experimental procedures, even the sample preparations, they are time consuming, but the results are very close. But we can predict, if suppose I want to make a product for any particular composites, we can applying the modeling approaches. We can applying the modeling approaches for that particular composites or for any materials, and we can predict the behavior of that composite by these approaches, sir. So the objective by this work is basically, sir, here I'm taking the the objective of my work is to prediction of the properties. I am taking here density and the thermal conductivity, the two key properties for this paper. And epoxy and the polyester, I am taking two resins, epoxy and polyesters, and I am observing the combinations for both. So basically prediction the properties of the epoxy based composites with particular fillers with different volume percentage. What we are doing for the same for the experimental also. So I am using the analytical approaches. And definitely, I already told I am taking the density and thermal conductivity of the composite for this different volume fractions, sir. So these are the objectives of my work, sir. Come to the materials and methods, sir. Basically, I am taking the natural fillers. I am taking the fillers, not the fibers, because, sir, when you are taking the fibers and applying the modeling approaches, the voids are generated. So to avoid the voids for the analytical approaches, I am taking the fillers. Means I am taking the particles in fine size, maybe microns. So these are the particles for the particular materials, maybe coir, cotton is a filler, flax, SUNM, and sisal. I am taking for filler materials for my approach, and for binding this natural fillers, I am using the two matrix materials. One is epoxy resin, another is polyester resins. So these are the key materials for my work. And for this calculation of the properties, I am taking the two approaches. I will discuss in the next pages. The properties and of the fillers and metrics are taken from the various references, since these are the standard values. So I'm referencing various references, 9, 12, and so on. So these references are giving me the approach, what is the properties for the particular fibers or fillers and the particular resin. So here for the coir, I'm taking these are the values for density. It is tabulated here, and based on these properties, which is available in the literatures, I'm applying the modeling approaches, sir. So for the variation of density, especially for first talk about the density. So for the density variation, sir, I am using the rule of mixture. I am applying the rule of mixture. This is well-known theory given by the, it is a well-known theory given by the researchers. So it is a key theory. Every composite can be easily applied for this rule of mixture. So for density variations, I am applying the rule of mixture, sir, and it is quoted in the references as quoted in the my site. So for the variation of the thermal conductivity, I am using three models basically. One is the rule of mixture, other is the geometrical modeling, and third is the Maxwell models. So three modeling techniques for the thermal conductivity and a rule of mixture for the density variations. So now I'm coming to the plotting, sir. So these are the general resultant discussions for my paper. Here I am showing the result of variation of density with the volume fraction in epoxy resin. Epoxy is a matrix, and the various fillers, cotton, sisal, square, flex, and hem. These are the fillers, and these are the, here in x-axis we are getting the volume fraction of fillers in the epoxy matrix. So I am taking from 10%, 0.1 to 70% of the variations in the volume fractions. Means in the epoxy matrix, I'm using 10% of, let's say, cotton, 20%, let's say cotton, 30%, 40%, up to 70%. Similarly for sisal, similarly for the coir and different fillers. And I'm observing the density variations based on the rule of mixture and plotting the results. So here I'm plotting that, observing that the except the sisal fibers, these are the sisal fibers, sir. Except sisal fibers, all other fillers are showing the same trends, means increasing trends of the density variations. Means if you are increasing the volume fractions of the filler in the epoxy matrix, we are getting the higher density. Means if I am using the 70% of sisal for the particular epoxy matrix, so I am getting the higher density. But for the sisal, it is in downward, it shows the downward pattern, because it is due to the virtual property or basic property of the sisal itself. So these are the variations observed in for the density. Similarly, the second graph, sir, I am putting the variation of density with the volume fraction for in the polyester resin. Here I am changing the resin. I am not taking the epoxy as a matrix, and now I am changing the polyester as a matrix. So these are the variations. If suppose any researchers want to work on the epoxy, suppose want to work on polyester resin, so he may look out the trends or predictions how the material will behave after the actual manufacturing. So here the polyester is using as a resin matrix, and the fillers are same: cotton, sisal, coir, flex, and hem. And same patterns are observed, but the definitely minute changes are observed in the properties. Let's say 1.3, 1.28. So minor changes are there due to the properties changes in the polyester, sir. So these are the patterns for the sorry, these are the patterns for the variation of density with the polyester resin, sir. So it will definitely helpful for the researchers to work on this area. If suppose any researcher want to work for the 40% fillers, 40% fillers for the sisal, so he may predict the performance of the metric for the material, how the density will observe. Maybe definitely some variations are there due to some assumptions in the modeling approaches, and the experimental approaches are there. So it may be adjustable when you are exactly doing for the experimental work, and you have to consider this assumption, sir. In the third graph, sir, I'm plotting the plot for the thermal conductivity, how the thermal conductivity behavior with the volume fraction changes in the epoxy resin with different percentage of filler. So here it is observed that as we are increasing the volume fraction of the filler in the matrix, the conductivity of the material decreases. It is highest at the 0.1%, yeah, 10% of the fillers, and it is lowest at the 0.7% of fillers. For suppose for the cotton or for the any materials, but the trend is downward. If you are increasing the volume fractions, your conductivity will decreases. So this variation is observed by the rule of mixture, sir. It is the rule of mixture variations. Similarly, that can be tested by other models also in the second graph. And the next graph, sir, it is tested by the Maxwell model, sir. In the Maxwell models, here they are giving the equations for the same. So here also the same pattern is observed, but it is the variation, the properties are too high. Means it is up to 0.1%, it is very highest value, and it is 0.7, it is close to 0.1. So the Maxwell model shows the downward positions, meant up to very close value as we are going for the higher percentage of volume. So the properties are very close to the 0.1 watt per meter Kelvin for the conductivity. So different models are tested for the particular same fibers, fillers, and same epoxy materials. In the last, I am applying the third models. This is basically geometrical model, sir. Here in geometrical model, here is the geometrical model.
Yes, Manoj, these are the existing models.
Yes, sir. These are all our existing models, sir.
So you have tried your samples with these existing models.
Exactly, right, sir. Bilkul.
So there is no similar kind of work is available in the literature. These
Yes,
same
sir.
models with the same epoxy and this.
Sir, same various models are available. Various
Because
works are.
this is very common resins, the epoxy and that one, the second one.
Yeah.
So
Yes, sir.
maybe a few other researchers also done these kind of testing on these models.
Bilkul. Sure. Definitely, sir. Lots of works are available in the literature also, sir.
So what
But
exactly you did in this? And I just want to search a novelty in this work.
Basically, a lot of works are available in this particular area, sir. But basically, the here I am applying the coir, flax, hem, cotton, and sisal. All this combines at a particular platforms. So this type of work, individual work, all combined work will not available in the literature, sir.
These fillers are not used with these resins. You want to say that, na?
Yeah.
Okay.
And second is, sir, these fillers are not applied to the polyester also, sir. So I'm applying the polyester second resin is here.
Fine.
Yeah. Sure.
Fine, proceed.
So these are the changes, sir. So these are the models, basically geometrical model for the epoxy matrix. So for conductivity, I'm testing 3 models, and for the condensity, I'm using 1 model, sir. And I'm observing the variation of properties for particular models. So these are the works for my paper, and I'm concluded. I am observing the density and thermal conductivity of any fillers when you are using for the epoxy or polyester with different filler fractions. The properties are changes, and as I am applying these models, and I am observing that these models are not exact agreement with the experimental results, but close to the experimental results, and this giving some predictions towards the behavior of the materials. Hypothetically forecast. If you are going for the experimental work, researchers have to do for some more attentions on the assumptions made in this particular models, and then definitely the results will close to the exact values. Due to participation, I am giving here, this variation are due to the voids. Why the experimental work and the modeling works are deviate, basically due to the voids. The various voids are there when you are preparing the composites experimentally. Some voids, air traps are there. So this may changes the properties. Some moisture absorptions are there. If fillers absorb the moistures, so this for moisture absorption is also changes the properties. Even some fabrication procedures. Suppose I am using some hand lab process. Some researchers are using the compression molding process. Some researchers are using other techniques. So the fabrication process or procedure also affect the results. And definitely some other factors like environment factors and some temperature factors must be counted during the fabrication of results. So it may be differ from the experimental value due to this variation, sir.
Mr. Manoj, in what technique you have used for sample preparation?
Sir, I'm not experimentally preparing the sample, sir. I'm
applying the simulated
modeling. Yeah, simulating them.
In which platform?
Sir, it is in the basically I'm using the analytical approaches. Some models are there, Maxwell models are there, geometrical models are there, rule of mixture models are there. So I am using this and doing the calculations in Excel, on Excel work.
Okay. It's a theoretical. It's a theoretical work.
Yeah.
Okay, it's a theoretical.
So don't you feel that you can also develop your own model?
Yeah, definitely, sir. I'm going for this particular work, but it is a pre-work for this particular work. I'm trying to develop new techniques for my work.
And I think there are few tools also available where you can
Yeah.
simulate these
Yeah.
things.
Yeah, sir. I'm trying to going for ANSYS also, sir. I'm trying to work
So
on ANSYS software.
definitely you have
Ah.
measured these two parameters theoretically, density
Yeah,
and
yeah,
this.
yeah. Sure.
electricity.
Sure. Right, sir.
So you just try to get more experimental plus model based approach, no?
Yeah, bilkul,
So
sure.
you develop a model so that you can claim something, because
Yeah.
in this everything is existing and you have just tried these filler items with these resins.
Yeah.
Okay.
So have you used, sorry, have you used ANSYS for modeling all this?
Sir, now I'm learning for the ANSYS, and in this paper I'm not using the ANSYS, sir.
Okay. Thank you.
So these are the key references. Thank you, sir.
Yes, if anyone else from the audience. Yes, Dr. Soman Shah. Yes, sir. You can
Yes,
say.
thank you. I have one question.
Sir.
Because you are calculating all the properties like density, thermal conductivity, I think there is no need for using any simulation software, because you are using some built-in mathematical model, theoretical model,
Yes, sir.
like Maxwell model, something like that.
Mhm.
So you are talking about some difference between experimental and theoretical.
Yes, sir.
What is the maximum deviation you got? Can you show me the percentage deviation between the experimental and theoretical value?
Sir, I'm not performing experimental work in my work, sir. I'm just.
But are you not comparing
Yeah.
with the?
Yeah, definitely, sir.
Do you have
Definitely.
any result or anything to show us?
Yeah, sir. I have gone through it. When we're going for the variation in the, it's up to 20% to 30%, sir. If suppose for the particular density, because the voids are there, moisture absorptions are there, even procedures are there. So
Okay,
changes are there.
can you show me the slide for density or any density that you have
Sure.
presented here?
Sure. Is it visible, sir?
Okay.
Okay. Yeah.
That will be fine. So
Yeah.
these are, I think you have used some model to calculate this density, right?
Yes, sir.
Okay. So I think, and if you have the experimental result,
Yes,
you have some experimental result, and you can make you can do some cut fitting or something like that, and get your own model.
Yes, sir.
And then you can compare your result with this one.
Yes,
and that
sir.
will be the best way to make this deviation as less as possible.
Sure. Bilkul.
So I will
Percentage
suggest
of
you in future, rather than using, because I know I was working with nanofluid, and they are using some model for density, viscosity, thermal conductivity, and with comparing with the experimental result, we found that there are a lot of deviation.
Yes, sir.
So better than using some, this is all traditional model, Maxwell or something like that.
Yes,
you can use your own build, some polynomial model or something like that, which match the experimental result more closely, and you can suggest your correlation or your equation for calculating density more accurately for the other research.
Yes, sir. Definitely. Sure. Thank you.
Anything else from anyone? If anyone want to ask something, otherwise we need to move further. Next participant is Mohammad Tushair. Mohammad Tushair.
Sir, may I leave, sir?
Yeah. If you want.
Thank you for valuable suggestions, sir.
Yeah. All the best here. Yes, Mohammad Tushair. You can share your screen.
Yes, sir. So I'm Mohammad Tushar Mahmood, currently pursuing my undergraduate degree in mechanical engineering in Bangladesh University of Engineering and Technology. Sir, we have worked on MHD mixed convection in a triangular cavity with heat conducting rotating cylinder. First, if we look at the non-dimensional parameters that we have used here to get an idea about the nature of the convection in the system, we have used the Richardson number. If the Richardson number is greater than 10, then we can say that the convection is mainly dominated by natural convection. And if the Richardson number is smaller than 0.1, then it can be called a forced convection. And if the Richardson number is in between 0.1 and 10, then it can be called a mixed convection. We have worked on mixed convection, and other non-dimensional parameters are Richardson, Reynolds number, and Grashof number. Richardson number mainly focuses on the forced convection. It gives us an idea about how the intensified the forced convection is. And Grashof number is the parameter that we can so that we can understand the intensity of the natural convection. So we have done some literature review that Mr. Nahak and others, they have investigated the effect of mixed convection in a triangular cavity with circular cylinder. And Hussein et al. They have investigated the entropy generation in a 3D triangular cavity. Hawk and others, they also have done some work on this particular region. Somro and Sean also have done some research, and after doing the literature review, we come to the conclusion that we can work on the enhancement of thermal performance under a magnetic field for mixed convection heat transfer. We have used a triangular cavity. The upper surface of the cavity is at a higher temperature and the side walls are at a lower temperature. And inside the cavity, we have placed a rotating solid cylinder, which is also heat conductive. So if we move on, our objectives was to develop mathematical models for the problem, and we have solved the mathematical equations and validate the mathematical model numerically using Galerkin finite element method. We also have used some non-dimensional parameters like Richardson number, Grashof number, and Reynolds number, as I have said before, to get an overview about the heat transfer rate. And we also have investigated the effect of varying Hartmann numbers, which is used to get an idea about how the intensity of the magnetic field is added to the system. So here you can see the physical model. We have used a triangular cavity, right angle triangular cavity. The left wall is adiabatic and the upper wall is at a higher temperature and the side wall is at a lower temperature. We have used air as the working fluid, and the rotating conductive cylinder is made of AISI 1010. Both are at the thermophysical properties are given at 300 Kelvin. So if we look at the mathematical formulation, these are the formulas that we have used: the continuity equation and the Navier-Stokes equation and the energy equations. We have solved these equations using Galerkin finite element method in Thomson multiphysics. So here are the boundary conditions. As I have said before, that our upper surface or the top wall is at a higher temperature. So as we have used the non-dimensional method, so we use the temperature to be 1 at top wall, and the inclined wall was the cold wall. So we have assumed the wall temperature to be 0, and the left wall was adiabatic, as you can see. And the cylindrical wall, there is a heat transfer in between the heat conductive cylinder and the working fluid. So if we move on, then as you can see, we have simulated the system in Thomson multiphysics using Galerkin finite element method. And these are the optimum mesh informations. So we have validated the work of Somro and others and get a convincing result that we can do our works here. So if we move on to results and discussion, we can see that we have used the rotation of the cylinder for we have get the results of both clockwise and counterclockwise rotations. As I have we have already seen that the recession number actually represents that the convection is, however, natural or forced convection. For lower recession number, the convection is mainly dominated by forced convection. As you can see that for lower recession number, the forced convection is dominant, which is visible here. The rotating cylinder is guiding the flow here for recession number equal to 0.1. And if we increase the recession number, the flow is dominated by natural convection. So the streamlines become random. And also, as the upper surface of the wall is hot and the side wall is at a lower temperature, so the if we do not use any rotating cylinder, then the convection due to natural density variation was supposed to go clockwise. So if we use a counterclockwise rotation in the cylinder, so that means it will affect the natural convection. So we can move on and see here that for clockwise, okay, we have used another non-dimensional parameter, which is a performance parameter, Knudsen number, which represents that how much heat is transferred to the working fluid here. So we can see that for clockwise rotation of the cylinder, as it is favorable to the natural convection. So if we increase the recession number, the Knudsen number also increases and it doesn't change that much. But for counterclockwise rotation, as it is not favorable, so as the recession number increases, the dominating natural convection is affected by the slow but forced convection actually. And after when the natural convection become dominant so much, then the Knudsen number also increases. And there are the isotherm plots in the system. Here we can see the isotherm plots for counterclockwise and clockwise direction for the different recession numbers. Okay, now if we use the Hartmann number, which is the magnetic effect that we have used a magnetic field from left to right. So under the magnetic field, the streamlines gets distorted, and the magnetic field actually prevents the flow to be random, and it try to stabilize it. So for an if we use a magnetic field, then the heat transfer is effected. Here are the isotherm plots. Here you can see that with and without Hartmann number, which means if we use a magnetic field from left to right, then the Knudsen number is decreased as the flow is stabilized by the magnetic field. So the heat transfer rate is higher for a free in a system without MHD effect. So we have shown here some other parameters, like if we increase the Reynolds number, which I have already told that the Reynolds number represents the forced convection. So if we increase the Reynolds number, then the flow is dominated by the forced convection. Though we have, as we have made constant the recession number, so it does not affect that much. As we change the Reynolds number, the gas number changes accordingly. So here are the isotherm plots for this. Yeah. So now if we get to the conclusion that we have already seen that the flow becomes more random with increasing recession number as the natural convection property dominates. For lower recession number, the forced convection is dominant. The rotating cylinder is guiding the flow. But for higher recession number, the natural convection is guiding the flow. So it is not around the circular rotating cylinder. And the heat transfer is greatly affected by the magnetohydrodynamic effect, as we have seen. The Hartmann number, as the Hartmann number increases, the effect of recession number becomes less visible. As we have seen that the Hartmann number or the magnetic field tries to stabilize the flow. The heat transfer is enhanced significantly when the rotating cylinder rotates clockwise. As we have seen that for the system, the top surface was at a higher temperature and the side wall was at a lower temperature. So the natural convection was more likely to move the fluid clockwise. So if we rotate the cylinder clockwise, then it helps the flow. So the heat transfer rate also increases. With MHD effect, the heat transfer decreases for both clockwise and anti-clockwise rotations. So these are the conclusions, and there are some references that we have used in this paper. And we would like to thank CFD research group of our mechanical department of BUET for providing continuous support throughout our research works. Thank you, sir.
Yeah, very, very nice, Mohammed Tushair. So my query is very simple, that why this MHD having this negative effect on heat transfer? What exactly is the logic behind that?
Actually, sir, as we have seen that if a charge or something moves in a magnetic field, then it tries to neutralize the movement or the velocity. So I think that because I really don't know that if the fluid has any positive or negative charge, but I think that the magnetic field is trying to stabilize the flow. So maybe that is the reason.
Just a minute, Tushar, you can show the mathematical model. The MHD effect is there. The previous slide.
So I think, sir, you have developed both things, mathematical model as well as you have simulated this on a particular tool.
Yes.
On the
they have used COMSOL multi-physics software.
Yeah.
Software. And you can see in the Y momentum equation, the Hartmann number, the magnetic field is there. So actually it reduces the velocity, and when the fluid motion reduces, and it will reduce the heat transfer rate as well. So with the increase of Hartmann number, so the fluid motion subpace and the heat transfer rate decreases. That's the another reason.
Yes. Now it's
actually they are third year students. They don't know too much physics. There's normally undergraduate third year students.
Yeah. Along with you senior professors, the student.
So yes, I am guiding them.
Job, sir.
They are interested on research, so I am guiding them and ask them to participate in this conference, and they are very much interested. Even though their term final examination is going on, but they are interested to present the paper here. So I
very well presented and very well contributed, sir. So nice talking to you also, Dr. Suman.
Thank you.
Okay, fine. So Tushar, can you tell us one more thing, that you have these type of conventions, so practically where we can use these the result of this work, how can we relate with the practical life, or where, in which areas we can utilize these outcomes?
So it can be used in so many areas, like solar receivers exposed to wind currents and electronic devices cooled by fans, and heat exchangers placed in low velocity environment where the mixed convection is more dominant, as the natural convection and forced convection both plays some roles. And also we can use in some nuclear reactors cooled when they are suddenly have emergency shutdown. And also thick-walled ducts, furnace design, so many application areas for this mixed convection area. There is.
Fine. Sir, Dr. Rana Mukherjee, sir.
Sir, you are muted.
You are muted. You are muted, sir. Unmute yourself, Rana, sir.
Yeah. I don't have any queries, sir. Everything was self-explanatory.
Fine, sir. Fine. So I congratulate Tushar. Very good, well presented. And also namaskar, Sumanji.
Thank you.
Definitely we will meet somewhere, or we will communicate.
Yes, sir, we are looking
in
forward
future also.
participating next conference. Inshallah.
Yeah. Sure. So I think no one is left here in this session. All the presentations have been done. So Rana sir, you and me, we compile our different sheets and then we send to the conference chair.
Yeah, definitely.
Do you have that particular?
Yeah, I have that sheet. I have. Yeah.
Okay. So you can mark there and you can send that sheet to the conference email ID.
Okay, sir.
Okay. So Amit sir, we are leaving. All the presentations are done. Okay, sir. Rana sir, goodbye. Take care.